In the silence of space, something is pulling us in. Black holes, capable of swallowing light itself, remain one of science's greatest mysteries. But what if they're not just destroyers? What if black holes are actually the key to time travel? Today, it's not science fiction speaking, it's science itself. Are you ready? Because on this journey, we're going to push the limits of time.
First of all, let's learn how a black hole births.
For the first time ever, astronomers might have witnessed a star actually become a black hole right before our eyes, or telescopes. In this visible light image from the Hubble Space Telescope, we can see a large star about 25 times the mass of our Sun, around 22 million light-years away in the galaxy NGC 6946. This was in 2007. But in a Hubble image from 2015, looking with the same filters at the same wavelengths, the star appears to be gone. One possible explanation? The star died and became a black hole. But it gets weirder. The most prevalent theory for how a black hole forms is through a supernova. If a star is big enough, at the end of its life it will eject its outer layers at high velocity in a massive explosion, while the inner core collapses into a very tiny space, creating a gravity well so great that light can't escape. Literally a black hole. So did we see the star go supernova? No, not really. A team of astronomers was monitoring the star with a large binocular telescope in Arizona and saw the star get brighter in 2009, but not nearly as bright as a supernova. They call it a failed supernova. The star does expel its outermost layer, but relatively gently and not in a big explosion. Okay, so the star got brighter in visible light in 2009 and then disappeared in visible light. How do we know it's not just hidden behind a cloud of dust or something? The team checked for that. They looked at infrared observations from the Spitzer Space Telescope, which would be able to see the heat of dust warmed by the star. What we see with Spitzer is there is some emission in the mid-infrared, but it's fading and fainter than what you would expect to see with a hidden star. The team thinks instead that this infrared light is from the heat of gas falling back onto the newly formed black hole. To help confirm that the star is now a black hole, the team plans to analyze observations taken with the Chandra X-ray Observatory, which would be able to reveal X-rays being emitted by the gas falling into the black hole. The team also wants to continue monitoring the star's location in visible light with Hubble, in case the star is still there and reappears. And they'll want to look at the location with the upcoming James Webb Space Telescope to check if there's a surviving star hidden by cooler dust than can be observed with Spitzer. So if this really is a black hole birth, what does that mean for astronomy? First of all, this would show that a star doesn't need to go supernova to form a black hole. Astronomers actually haven't seen as many supernovas occur with the largest stars as they would expect to see, and they've been wondering why this is. Perhaps 10 to 30% of massive stars don't go supernova, and they're still able to simply form a black hole. If future observations confirm this team's findings, this would be the first birth of a black hole ever witnessed and the first failed supernova ever discovered, both of which would usher in an exciting era of astronomy research.
We've just witnessed the birth of a black hole through NASA's eyes. But what are these colossal structures really? Let's take a closer look at black holes. Let's begin by understanding what black holes really are. A black hole forms when a star collapses under the force of its own gravity. The collapse is so intense that it creates a point known as a singularity, surrounded by an invisible boundary. The event horizon. Nothing, not even light, can escape it. Black holes are among the most dense and extreme objects in the universe. They act like gravitational monsters, devouring anything that comes too close. But did you know their incredible power affects more than just matter? Black holes don't just swallow, they bend time itself. And this is where world-renowned physicist Albert Einstein enters the story. According to his general theory of relativity, black holes don't just trap matter, they also distort time. The greater the mass, the slower time flows. Near a black hole, time bends, literally. So much so that spending just 1 hour near a black hole could equal years on Earth. But are these massive giants only found at the centers of distant galaxies? Not quite. In fact, in 2022, scientists discovered a black hole remarkably close to Earth. Named Gaia BH1, it lies only 1,560 light-years away, the closest black hole ever detected. Discovered through the Gaia telescope, this black hole orbits a star in a binary system, right in our own galactic neighborhood. The existence of such a cosmic giant so close to us suggests that black holes may be far more common than we thought. So if black holes can warp time, is that all they can do? Or can they do more? What if black holes are time travel itself? If black holes can distort time so dramatically, could they serve as gateways through time? This is where one of the most mind-bending theories emerges. Black holes might be, in essence, cosmic time machines. Some scientists believe that rotating black holes, known as Kerr black holes, may twist the very fabric of space and time into tunnels. And this idea isn't just a product of science fiction. Real scientists have taken it seriously. Among them is Kip Thorne, one of the most respected minds in theoretical physics. According to his work, 2 black holes could potentially be linked by a tunnel, a wormhole. In theory, such a tunnel could allow you to cross time itself. But what if these structures are unstable? What if they collapse the moment you enter? These theories are thrilling, but reality is always more complicated. While some scientists embrace the possibility, others believe the universe simply wouldn't allow it. Stephen Hawking suggested that time travel may not be physically impossible, but that the universe may actively prevent it to avoid paradoxes. In other words, just because something is possible doesn't mean it will ever be done. So, can we really know? Can we draw a conclusion from all this? Science gives us hints, but the answers remain in the dark. Theoretically possible. Black holes are structures that manipulate time. They can slow it, bend it, perhaps even move it forward. But for now, these remain only theories. We haven't even gotten close to entering a black hole, and maybe we're not supposed to. What should our goal be? Perhaps time travel shouldn't be physical, but mental. By understanding the past, we shape the future. Black holes remind us how fragile time is, and time might be the most valuable thing we have. And now, it's your turn. At the end of this documentary, only questions remain. Do you believe black holes could enable time travel? If you had the chance, would you step into one? If you could bend time, would you go to the past or the future? Let's meet in the comments. Because this isn't just a documentary, so it's a conversation. And maybe together, we'll solve one of the universe's greatest mysteries.
Don't forget to follow us for more videos like this.